Hello, I'm Kamal Takodra. I'm a technical marketing engineer in the Aruba Switching Business Unit. In this 10.10 update, I'm going to be talking to you about IPv6 security enhancement, router advertisement guard, also known as RA guard. So in terms of solution references and features, it's very useful to go and see these two RFCs, 7113 and 4861. Also have a look at our ABC networking channel for Aruba on YouTube. You'll also find some useful information about IPv6 and RAs. As part of today's agenda, we will cover an overview of RA Guard, use cases for this feature, details about the feature, then some configuration and troubleshooting. We'll then move over to a short demo, and then we'll talk about some additional resources that are available to you. Overview: RA Guard router mode. Let's firstly cover off what is an RA. An RA is a router advertisement sent to hosts on a network to inform the nodes of how they should configure themselves or what parameters they should conform to in a v6 network. So the RA typically sends information to the hosts, which include things like the default route, the IPv6 network prefix, whether to use stateless or stateful addressing, and that includes things like the M flag if you're using DHCP v6 to make an address assignment, the O flag for additional information around v6, router preference, and many more parameters. Now, the RA being sent to hosts effectively is an attack vector which we need to protect against, because essentially we could get a miscellaneous RA or a fake RA coming in, as shown on the diagram in the right. So RA Guard helps us or assists us to protect nodes from false information. So let's look at the RA Guard enhancement. So first of all, just to let you know that RA Guard has been available on CX since 10.04. And in fact, it was available in what we call host mode. This is where RA packets received on untrusted ports are dropped immediately, typically LAN ports, client-side facing effectively. Then we have trust mode, which is effectively any RA packets received on trusted ports are forwarded. This is typically upstream of where we expect to find the RA. This was supported on platforms 6200, 6300, 6400, and 8360. However, for 10.10, what we're providing now is a policy to be applied on a trusted port or VLAN. We call this router mode. This allows us to differentiate on a trusted port. And in fact, what we can differentiate are these 6 different variables. And those policy options include hop limit, manage config flag, other config flag, router preference, ACLs, and we also have advertised prefix lists. Let's look at a use case. Here we have the situation where we have a legitimate RA and a fake RA or an untrusted RA coming over the trusted port. What we want to be able to do is to differentiate between legitimate RA and the untrusted or fake RA. And we want to be able to do that at the access switch. So blocking the fake RA and allowing the legitimate RA. And that's exactly what we can now do with 10.10 with router mode, where we can apply a policy to a trusted port or VLAN. So we can now further differentiate the RAs based on policies we apply on the access switch. So we can look at hop limit, which is very similar to TTL of IPv4. We can look at the managed config flag, which informs us that we use DHCP-v6 for assignment. Other config flag, router preference, ACL source match, which it looks at the actual source and allows or denies based on the source that's coming in. And then finally, the advertised prefix lists, which we can see or we know that should be allocated to our specific segment and allow that through. Let's look at the feature details now. So let's go over the feature details. RA Guard router mode is policy based and it must coexist with ND snooping. The applied policy will take effect only if ND snooping is enabled globally and under the VLAN context where RA packets are received. Policies applied on a VLAN will be effective only for the RA received on the ND snooping trusted ports which are part of that VLAN. Policies applied on a port is applicable to RA Guard trusted ports only. RA Guard policy applied on an untrusted port will be ineffective, which means that RA packets received on this port will be dropped without any inspection. Only a single policy can be attached per VLAN or interface at a given point in time. RA Guard policy cannot be applied to an interface where routing is enabled. And please note, by default, all ports are designated as untrusted. Policies applied on a port will always take priority over policy applied on a VLAN, and we'll see this later in the demo. If any parameters in the policy fail, the RA will be dropped. In other words, all parameters in a policy must pass to forward the RA packet. Supported on both multi-chassis lag ports and supported on lag interfaces. Note that RA Guard policy is not supported on VXLAN endpoints. And finally, RA Guard policy can be applied to ISL links of VSX switches, but it's not really required. Effectively, it's ineffective, as RA should already have been intercepted by the VSX peer. Let's look at some configuration and troubleshooting for RA Guard. Let's look at some RA Guard configuration examples, and firstly, let's look at the VLAN bound policy. The first thing you need to do is enable ND snooping globally. The second step is to define a policy. In this policy, I'm going to be checking for the O flag to be off. The third step is to enable ND snooping on the VLAN context and then attach the policy that you created earlier. And finally, you must ensure that you define a trusted port for forwarding or dropping RAs based on that policy. Next, let's look at a port-bound policy. So I'm using the previous configuration and adding to it. So the first thing we do is we're going to define an ACL here with a trusted RA source. In this case, it's 2001 DB8 COF : 10:2/64. So this will be the source that I'm effectively going to trust. Second step, create the policy with the ACL. You can see that I've added a match for the access list I created earlier. Step 3 is you attach the policy to a port. Here I've trusted it to the previous ND snooping trusted port. What happens here is the port policy overrides the VLAN policy. So the VLAN policy is ignored as the port policy takes preference. Let's continue the configuration examples and look at a port-bound policy with multiple rules. Here I've just added to the previous policy for the port. So the VLAN policy is ignored as the port policy takes preference. I've added multiple rules in the policy. All rules in the policy must pass to be able to allow the RA to be trusted and go through to the hosts. In this example, I've added a hop limit of the server, which the server must be between 3 and 30 hops to be trusted, as well as having the source address we defined earlier. Here I've shown some of the most useful RA guard troubleshooting commands. So we can see how a policy is configured. We can look at various statistics as well as clear them. We can also debug using ND Snoop. On the right, we can see the show ND Snooping RA guard policy. We can see where the RA guard is applied. Here we have got a policy applied on port 1152 and on VLAN 1969. And we know from what we've said that the port policy will take precedence over the VLAN policy. Here below, we see the output of regular ND snooping statistics, and we can see RAs that are being forwarded or dropped on the switch. Continuing with the RA guard troubleshooting commands, here we see a show ND snooping RA guard for a VLAN. We can see the policy which is applied. We can see the number of packets received, and we can see the number of packets forward in terms of RAs. And we can see the number of RAs that were dropped. We also see the reason for the RAs being dropped. And in this case, we can see it's because we hit the O flag counter and the access list is also incorrect. At the bottom, finally, we see a debug of ND Snoop. We can see that we've had a rejection, and the reason for the rejection of the RA is because the policy did not match because of the O flag in this case. Now let's discuss the demo that we're going to show next. Here we have a diagram of a demo that we're going to show. I have two 6300, 6302 on the left. That's going to be sending our RAs, and we've got a configuration of a local link. We've increased the RA interval here so we get more RAs. We've also set the other config flag to on, and then we've got the no suppress of the RA, so it means RAs are being sent. Both the switches are connected by port 1152. We have got VLAN 1969 on here. 6301 has the trusted port, and this will be where we're going to apply the RA guard policy. So let's move on to the demo. So just to refresh, I've got two CX switches here, 6302. This will be sending an RA or RAs on the network. And then I'm going to have 6301. This is the device under test. I've got a trusted port on VLAN 1969, and that's interface 1152. And that's where we'll be focusing most of our efforts. I've got another config flag set, as well as a prefix of a local link, which is sending RAs, and that's what we'll focus our basic demo around. So let's have a quick look at the config. I just do a show run. Let's have a quick summary of that. So the first thing is I've got ND snooping enabled globally. I've also got a number of ND snooping policies. They're empty, so they have nothing in them at the moment. You can see that this VLAN this interface we talked about has got ND snooping trust. So that's the port that we're trusting here on this 6300. And then finally, if I go up to the VLAN just at the top, you'll see I've got ND snooping configured on here too. I've also got no ND snooping ND guard because we're not showing that feature, but they can work in conjunction. So first thing I'm going to do, let's have a look at any RAs coming in to this, and a switch which should be coming in directly because I've got RAs configured from that other CX switch. So simply let's have a look at the ND snooping statistics. Do a show ND snooping statistics. We'll see that we've got RAs coming in and they're being forwarded, nothing being dropped at the moment, and that's what we're expecting because we've actually got a trust on this port, no policy attached, and RAs are coming in. So let's go and add a policy with another config flag on it. So I just need to go into the actual policy we had earlier, which is here. So I'm going to simply do a cut and paste. Look at the options I've got the other config flag here, so let's go with that, and we're going to have an option of, we can look for it as on or off. Our CX switch upstream is sending RAs, so sending other config flag on, so we'll put on. And then I need to go to the VLAN and attach the policy I just created. So let's quickly do that. So I've attached the policy that I created earlier. Show run, and you can see that now. So let's have a look at the statistics again. Again, we are having RAs forwarded, nothing dropped, but this time we've now got access to some more statistics around the actual RA. So I have a quick look here. So I just put in show ND snooping RA guard on VLAN 1969. You can see now the statistics here. So I'm still getting a RAs received and RA packets forwarded, and nothing's being dropped because the other config flag, we're allowing it through as being on. So let's change the policy now so we get some drops. So go back to my original policy, and it's just all the way up here. Let's change this so the other config flag is off. So we're now looking for an off here. However, the RA we are sending is other config flag on. So I'd expect to see some drops now. So let's have a look at the statistics. And as you can see now, we are now dropping RAs, but this is an overall summary. Just make sure that that is the only one incrementing, and you can see it's just incremented, whereas the other count for the forwarding is no longer incrementing. Yeah, so we're dropping RAs based on the other config flag, and now we can double check that by looking at the ND snooping RA guard policy stats. So let's have a quick look there. Show ND snooping RA guard on VLAN 1969. Now you can see that again we've had the received packets that previously forwarded, we've dropped 10, and then if we drill down a bit further we can see that the reason we're dropping those packets is because of the other config flag has been set or not as we were expecting it, and therefore we're dropping it, and that should have incremented a bit more. Yep, and as you can see that's incremented. Okay, now next thing I think is what we'll do is we'll apply another policy. This time we'll do it on on an access list, looking for the source of the RA. So typically you'd be doing an allow for a known source, but we'll manipulate this with an allow and a deny to make sure that it's working as we expect. So if I just do a show access lists, I've already configured a couple of access lists. I've got a deny access list of this v6 address, which is of my upstream CX device, and then I've also got a deny on there. So let's actually apply that to a VLAN first, and then I'll also do it to a port. So the best thing to do now is apply this ACL to the VLAN. So let's go back to our policy on the that which I've attached to the VLAN, and let's have a look. Let's have a look at it just to confirm. You can see I've got this other config flag off. Let's remove that. And I'm going to do a match on an access list, which was named RAD. And that's it. Hit return. So now we have just changed the policy. It's still being applied. I'm expecting now to drop further RAs based on the source address. So let's have a look at the statistics again. They will have obviously incremented. And now we can see some drops on the RAs. Let's just make sure it's incrementing. Yep, so the 46 is static and the 55 is incremented. Now we can drill down on the VLAN as well. Make sure that the reason we're getting the RAs dropped is because of access list, and obviously we can see that we're dropping RAs, but if we drill down further, we're also dropping them because of an access list error, or it's being blocked because we're not allowing that address through, and that will be incrementing. We can see it's incremented. It was 8 previously and now 11. We still have the historical statistics. If you want to clear those statistics, then we have a way of clearing them. You just clear ND snooping RA guard policy statistics, and that's VLAN 1969. I should have cleared them, and we can see that that's incrementing. Excuse me. We can see that is now the error. We've cleared everything. We can also look at the debugs that I mentioned earlier. So let's have a quick look at the debugs. So let's just first of all clear debug buffer. Show debug. I think I've already possibly got that on. Yeah, I've got ND snooping for all on. So if I do it, show debug buffer, we are getting a RA packets being rejected on VLAN 1969, and it's saying the RA packet source IP is not matching because we've got to deny there, and it's not matching what we want to go through on a policy, and hence the drops. So now something I mentioned earlier was in my slides is that obviously the port policy takes precedence over the VLAN policy. So let's take that same policy or override the policy. So what I'm going to do is I'm going to take this other policy and I'm going to match the access list, which I called RA permit. Now, all I've done is created this new policy, but what I'm going to do is I'm going to apply this policy while the VLAN policy is enabled, and then attach it to the actual port itself. So if I just go interface /52 and then I just attach this policy, attach the policy itself. So attach policy is the keyword. Name the policy. So now what I've done is I've attached a permit onto the port policy, allowing the RAs from that specific address. So if I just now look at the statistics, we should see RAs being forwarded, and that should be incrementing now. So we've got 51, and we should see the 103 become static. And there you are. So we had an increment of RAs, but the drops have remained static. It's because I overrode the policy by applying it to the port. There you are. We can see that's static on the drops, but actually being forwarded on because of the new port policy. So I can we can confirm that by actually looking at the statistics again. So we can do a show ND snooping RA guard statistics, and this time we'll look at interface 1/1/52, and you can see that I'm not getting any drops and showing that it's passing. So there's no access list. I can, if I look at VLAN 1969, that should also be static. We've just got the historic data. Nothing happening because the port policy has taken over. So let's just have a look finally at the debug. Let's clear the debug buffer and show debug buffer. And we are seeing the packet is being forwarded on that VLAN 1960 after RA policy was validated. Again, received on trusted port, forwarded. So we're also getting the forwarded information, why it's being forwarded, because of the RA guard policy is effectively letting it through. There is much more to configurations on this, but this was just a simple introduction to the new feature of RA guard policy. Thank you for watching. Resources for RA guard. Thank you for watching. I hope this was useful for you.